All right, for this question, you may find the following formulas related to a cone useful. Volume of the cone is 1/3 base area times the perpendicular height. The curved surface of the cone is pi r slant height. The slant height is called L. A form or construct a storage tank as shown in the diagram. Here it is. Below. The shape of the tank consists of a cylindrical body of height 3.5 meters, right? And diameter 8 meters, and a conical roof of vertical height 1.2 meters. We're using pi as 3.14. All right, let's see what they want. All right, so here they're saying calculate the slant height L of the roof of the tank. So we want to find the slant height L. Now let's take a look at what is going on. We were told that the diameter is 8. So if the diameter is 8, then that means the radius is half of that, because half of a diameter would give me a radius. All right, so 4 meters would be my radius, and then the slant height here, this is the center and this is the circumference, so this is 4, which is a half of the journey. All right, so it is 4 centimeters for the radius. If you notice though, the fact that we have a right angle here, the fact that we have a right angle there is telling us that we can use the Pythagoras theory in an effort to solve this problem, to find the slant height. So the slant height L square is equal to 1.2 square plus 4 square. We're looking at 1.2 square is going to give us 1.44 plus 4 is 16. When we add this, we'll get 17.44. To find L, we have to take the root of 17.44, and that will land us that L is equal to 4.18. All right, so 4.18 meters. I put centimeters here by error. This ought to be meter. So we have 4.18 meter, and I could just put it along here. So L is equal to 4.18 meters long. All right, so that's the slant height there. So we would have picked up the mark there, having answered that using the Pythagoras theory. All right, let's continue. Let's see what else that we have there going on. All right, so the other question says, assume that the storage tank is completely sealed and is filled with diesel from an opening at the top. Find the capacity in meters cubed of the tank, inclusive of the conical roof. All right, so if we want to find the capacity, we're thinking of two things here. One, we're thinking of the volume, or slash, we want to say the capacity, basically, all right, of the cone. So we're talking about so the volume or the capacity of everything there. All right, we're looking at the cone, so we're talking about the capacity of the cone, and we want to add that to the capacity of the cylinder. Now remember though, for the cone, it's 1/3 pi r square h, and I'm talking that height, conical height, and then this is just pi r square h. We put those together and then we would have gotten easily our thing. Remember though that the radius is 4 and pi is 3.14. So this is 1/3 times pi, which is 3.14, times the radius, which is 4 square, times the height, which is 1.2 meters. We want to add that to the capacity of the cylinder, which is pi, which is 3.14, times 4 square, times the height, which is 3.5. All we have to do is just to put our math together. So we're talking about 3.14, yeah? So 3.14, here's my calculator. 3.14 we multiply that by 4 times 4 is 16, multiply that by 1.2, yeah, and then divide that by 3. So we're getting 20.1. All right, so that is 20.1. For the other section, 3.14, we're timesing that by 4 times 4 times 3.5, and we're getting 175.8. So if we put these together, 175.8 plus 20.1, we're getting 196. It's actually 195.9. Let us look if there's any specific. All right, good. So basically, this is approximately, 196 cubic meters. That's what we have right there. All right, give and take, I'd round off a little when we're going. So basically, that's what we have right now. All right, now show that the total curved surface of the tank to the nearest square meter is 140. Now, if we're talking about the curved surface, we're talking about the curved surface of the tank. Curved surface of the tank. Curve. Right. The curved surface. So if you're talking about the curved surface of the tank, basically what we're actually looking at is, hear this, we're looking at the curved surface of the cone. Yeah, so we're talking about the curved surface of the cone, as well as we're talking about the curved surface, yes, of the cylinder. So we're talking about putting together those. The formula that was given up here for the curved surface of the cone was actually pi r L, and L refers to the slant height. And we're going to be adding that to 2 pi r h. And so basically, so these two will find the curved surface, one for the cone and the other for the cylinder. Let's just put in our formulas. 3.14 times radius 4 times the slant height, which is 4.18, plus 2 times pi times r times h. There it is. So let's finalize everything here. Let's go on our calculator and see what we got. 3.14 times 4 times 4.18. So I'm getting here 52.50, and then the other part is 2 times 3.14 times 4 times 3.5, and I'm getting 87.92. So we want to add these together, the 87.92 plus the 52.50, and I'm getting as my answer 140.42. But remember, they wanted us to round this up to the nearest square meters, so then this will be rounded down to 140 square meters. I wrote cubic by error. Right? So here it is, that we have proven that it is equal to 140 to the nearest square meters. So there is that. All right, let us go to the final question. All right, so it says the farmer wishes to paint the exterior of the tank. Given that 1 gallon, which is 1 gallon is approximately 3.79 liters. So given that 1 gallon of paint covers 30 square meters of the surface. All right, so we're talking about that external curved surface, All right, it says determining the amount of paint in liters needed. All right, no problem. We are noticing here that we got the fact that one gallon, right? So this is like 1 gallon, and this 1 gallon could give me 30 meters square. 1 gallon give me 30 meters square right there. 1 gallon. All right. And then now we want to know how many gallon would have given us 140 of that. Well, basically what I could do, I could just simply divide this 30 into the 140 to tell how many will be coming out. So basically, we're going to be looking at the number of, the number of gallons needed. So the gallons needed, I'm going to have it here, is going to equal to 140 divided by 30. And that is going to give us, that's going to give me, I'm getting 4.67. So 4.67 gallons would have been needed. But the question wants the answer in liters. So we're going to multiply. So 1 gallon give me 3.79. So I'm going to multiply this answer by 3.79. So 4.67 times 3.79. And it's going to give me 17.69, which is 17.6993. So I'm going to round it off to 17.7. Did they say to the nearest determinant? So 7.7 liters of paint. So it would have needed 7.7 liters of paint to do that. And there it is. Here it is. So thank you for watching Daily Maths Concepts right here. I'm suggesting that if you have not yet subscribed, please subscribe to the channel, right? Subscribe to the channel and share, like, and drop a comment. And if you have any questions, you could drop them right there and I will respond to them momentarily. Thank you one more time.